Next, what happened? Addition of more electronegative element, removing of what? Electropositive element. Addition of more electronegative element and removing of electropositive element is nothing but called oxidation reaction. Next, we'll see what happened. Reduction reaction examples. Next, again, addition of what here? Opposite, hydrogen. Addition of hydrogen. So you are adding hydrogen to this one. You got this compound. A reaction which oxygen is removing. Opposite to oxidation is nothing but called reduction reaction. Opposite to oxidation. Nothing but addition of hydrogen, removal of oxygen. You see, you are removed oxygen over here. Now this is called here reduction reaction. Addition of hydrogen, removal of oxygen is called what? Reduction reaction. Next, what happened? The third one, a reaction which electronegative element. In the previous case, if you add electronegative element, they are called oxidation reactions. Now here, what we are doing here? We are removing electronegative element. So remove one electronegative element here, chlorine. Your electronegative element is what beta here? Chlorine it is. So when you remove this electronegative element, then the reaction is called what here? Reduction reaction. Next, when you add electropositive element, add electropositive element here. Okay, then that is called what here? Reduction reaction. You see here, electropositive element is mercury beta. The electropositive element is mercury. How many mercury are there here beta? In this molecule, how many mercuries are there here? In this molecule?
2, sir.
Yes. Only here 2 molecules are there, but 1 molecule I am asking. The molecule is like this, HgCl2. This is one molecule. In this one molecule, how many are there? Only one electropositive element is there. One mercury, that is electro. When you write left hand side, that is electropositive beta. When you write right hand side, that is called electronegative beta. For example, tin, electropositive. This one will be electronegative. Left hand, electropositive beta. Right hand, in this way you can easily identify which is electropositive and which is electronegative. Now in this one molecule, how many are there beta? Mercury's electropositive elements, how many are there? How many electropositive are there beta? On product side. Anybody? In reactant side, one mercury is there. In product side, how many mercuries are there beta?
2.
2 are there. That means of a reaction in which electropositive element is added. Yes, one electropositive element is added. So which reaction it is called? Reduction reaction. So when you place everything, okay, all these things, what we are getting actually? For oxidation, what we are getting? First thing is what? Addition of oxygen. Second thing is what? Removing of hydrogen. Third thing is that addition of what? Electronegative element. Plus means addition beta, minus means removing. Understood? Fourth one is what? Removing of electropositive element. Okay? Plus means addition. Plus means what here? Addition. Right? Minus means just removing. Only shortcut I am writing. Removing here. Correct? Now, addition of oxygen, removing of hydrogen, addition of electronegative element, removing of electropositive elements, all these comes under what here? Oxidation reactions. Okay? But here in the reduction reaction, opposite beta. Now, removing of oxygen, addition of hydrogen, removing of electronegative element, and finally what happened? Addition of electropositive elements. Okay? In this way we can get reduction reaction. So next we go to next slide here. Redox reaction that involves electron transfer. I told you in the last class some contradictions will be there, right? Some contradictions will be there in which what happened? We cannot identify because which is electronegative element, which is electropositive element, identification is very difficult for me. So we take what happened in terms of electron. In terms of electron, if you observe, in terms of electron, what is oxidation reaction? Just simply loss of electrons. Okay, loss of electron is nothing but called oxidation reaction. Otherwise, you can also say increasing of charge also. Increasing of charge can be called also what happened? Oxidation reaction. Now, what is the meaning of increasing of charge? For example, +1 converting into +2. Increasing or not here? Increasing or not here? Otherwise, +3 converting into +5. Charge is increasing or not? Yes. So these reactions are called nothing but oxidation reactions. Understood better? Now here, remember, don't take minus better. Take only what positive charges only. Don't take minus value. Don't say what happened -1 to what -2. It is not increasing here. Leave it this one. Take only what positive charges only. Next, we'll take an example here. Now here in the first reaction, you lost first and second reaction. Do you lost electron or not? Tell me, Yota. Are you losing electron or not? Are you losing electron or not, better?
Yes,
Yes, sir.
Definitely. Definitely, these reactions are oxidation. Like one more thing, charge increasing or not? +2 to +3 increasing. Therefore, oxidation. 0 to +1. 0 to +1 increasing. If you don't write anything, if you write plus, what happens? Nothing but +1 only better. Both are what same. +1, both are what same. Next, reduction means what happened? Gaining of electron, and decrease in the charge. And the charge is decreasing, what happened? That is called what? Reduction reaction. Let me see this example. You are now gaining of electron or not? You see here. Gaining of electron or not here. See. You are gaining electron, converting into Cl minus, reduction reaction. Next, what is the decrease in the charge here? See, decrease in the charge means you can take like this actually. So for example, +3 is converting into +1. Decreasing of charge or not? +3 converting into +1 or +5 converting into +2. This is what decreasing of charge. Here 0 to -1 also. That means what happened? Increasing negative charge. Or you can also write increase in negative charge also can be called reduction reaction. Increase in negative charge also can be taken as what? Reduction reaction. Correct or not? Understood better? Let's see number of examples now. I already told you redox means red plus ox. Redox reaction. Red for a reduction, ox plus oxidation. A reaction that involves both oxidation and reduction, that reactions are called what? Redox reactions, right? Example, we'll take this example. Now I told you, this is elemental beta, correct or not? All elements will have what oxidation state beta?
So 0.
0. Molecular state, but it's a neutral, elemental state only. General fluorine available in the Cl2 only. So both these two will have definitely oxidation state will be how much better? Both these two will have. What is the oxidation state of between these two? Here it is 0 and here also it is 0. Right? 0 and 0. Now NaCl, when it forms NaCl, sodium get +1, Cl get -1. Sodium is getting, isn't it? +1, Cl is getting -. Why? Because sodium transferred one electron to what? Chlorine. Isn't it? So which is gaining here? Chlorine is gaining, sodium is losing. So whichever lose electron, that means sodium lost electron, therefore sodium undergoing which reaction beta? Oxidation reaction. Correct beta? Now Cl gaining electron, reduction reaction. Very simple we got. So Cl, chlorine undergoing reduction reaction, sodium undergoing oxidation reaction. And the overall reaction is what? The overall reaction is what reaction beta? The overall reaction is what example?
Redox reaction.
Redox reaction beta. Okay, the overall reaction is redox reaction. Now see here, in sodium 0 to +1. Okay, so positive charge increases, oxidation. 0 to minus, negative charge increases, reduction beta. Whenever you remember, when positive charge increases, okay, negative charge increases. In this case, positive increases, oxidation beta. Okay, negative increases, reduction. Understood beta. Sometimes what happens, positive decreases. That is also reduction reaction. Sometimes negative what happen? Also what happen? Decreases. That is also what? Oxidation. Okay, I'm writing over here. Whenever positive increases or negative decreases, that reactions are called oxidation reactions. You write in notebook beta this one. Whenever negative charge increases, positive charge what happen? Decreases. That will be reduction. Now here, no, don't get any confusion beta. Don't get any confusion. You don't remember these things because this will be definitely some type of doubts you will get here. You may get, even you may get something what happened, misunderstanding of also this. You may forget also this. So remember only this concept better. Positive increases, oxidation. When positive increases, negative should decrease here. Correct? If positive increases, negative should decrease. Next. For reduction, negative should increase here. If negative is increasing, positive will decrease. So this is no need to remember. If you remember this one, opposite it will be. If positive is increasing for oxidation, for same oxidation, negative will be decreases. If negative is increasing for reduction, definitely the positive will be decreased for reduction. Very simple to remember. But once you do the problems, it will be easily remember for you. No need to add anything. Now, if you see something, if, up to here, I think yesterday we discussed in the PDF format, textbook, we discussed that. But now let me take the next topic today. Now, one more thing I want to say here, one more thing. In nature, can you write only oxidation? Is it possible to write only reduction? Is it possible? Writing only oxidation and reduction, is it possible, beta?
No, sir.
No, impossible. You cannot write only oxidation or only reduction. Now you may say, sir, already I have written one example. No, here you see this one. Now you written only reduction here. So why you are saying only reduction is not possible? See, a reduction is only took place. Correct or not, beta? Here also what happened in the previous example? Only oxidation took place. Only oxidation took place, beta. Only oxidation. So you are saying something what? Sir, only oxidation does not take place, only reduction does not take place. Now, why you written this reaction? See, I have written only half reaction beta. I have written only half of the reaction. Remaining half of the reaction I have written here. To explain this example, I have taken half of the reaction only. The remaining half of the reaction, what will be for this one? Reduction. For next example, this is the half reaction beta. This is half reaction only. So remaining half reaction will be for this one, oxidation. So one more thing beta. Simple, I will say what happened. So something is, you are donating some rupees to somebody. If nobody is there, to whom you donate beta? Is it possible? Without, you want to donate some money to beggars. There are no beggars. Now how do you call as a donor now? Can I call you donor now? With there are no beggars, you cannot donate the rupees to anybody. Can I call you donor? Is it possible, beta? Is it possible? Yes or no?
No, sir.
Impossible. So without oxidation reaction, there are no reduction reactions in the nature. So redox reactions takes place in a complete reaction. Half reaction you can take that. Half reaction is a incomplete reaction. In incomplete reaction you can take that. But in a complete reaction, compulsory it is a redox reaction only. I think everyone understood the rules. At least the rules are understood, I think, everyone. Now let me take a beautiful example, beta. It's a very important question, beta. Very important. What is this experiment? They taken a beaker, right? In this beaker, which solution is there, beta? Copper nitrate solution is there. Copper nitrate solution is there, or copper sulfate. You can take copper nitrate, or you can take a copper sulfate solution. In the beaker, which solution you are having, beta? Copper nitrate or copper sulfate solution you are taking. This is the solution of what? Copper nitrate or copper sulfate. Any example you can take, beta. Copper nitrate or copper sulfate. Copper must be in copper plus 2. Here also copper must be in copper plus 2. Now in this, which rod you are dipping, beta? Zinc rod. Which rod it is? Zinc rod. And here also you are dipping which rod, beta? Zinc rod you are dipping. Correct? So what is the experiment here? Zinc rod is dipping in copper plus 2 solution. Here copper plus 2 solution means it may be either copper nitrate or copper sulfate. In both the case, copper oxidation state is copper plus 2. Now after some time, now if you observe what is the color of this copper nitrate or copper plus 2, which color, beta? It is blue color. It is having blue color, beta. It is having blue color. Here also it is having. I will explain here. I can't write what I will do one thing here. First of all, we'll take the what I'm doing here. Which color it is having now? Blue color it is having. This solution is having blue color. I'm writing over blue color. Here also the solution is having blue color. Otherwise, I'll do one thing here. Now this is the blue color solution. Which one it is? Copper plus 2, beta. It's a copper plus 2. Copper plus 2 means nothing but what? Copper sulfate or copper nitrate, beta. Copper nitrate. Before the experiment, this is before experiment actually. Before you are not starting the experiment, at that time it is blue color, beta. It is blue color now. Now once if you dip a zinc rod here, now you are dipping a zinc rod here, which is having something colorless. Colorless, I am taking beta upper. I am taking a colorless something this color because here no colorless. It is also showing same color. Best. The colorless I am showing here in terms of what? Black color beta. Okay, this one I am showing. This one you are dipping here into blue color. Into blue color, I am dipping something. Which one it is? Zinc rod. Just a minute. This one is a zinc rod. So after some time, after something 10 minutes, after 10 minutes, what happening here?
So the solution will turn to green.
The solution does not loses its blue color, isn't it? It becomes what happened? Colorless. That fade. Otherwise, what happened? Blue color will be become fade. Don't go to the green color, beta. But the colorless, otherwise what happened? Almost becomes fade. After certain one day, what happened? Completely becomes colorless. Okay. But immediately what to observe here? Fading of the blue color. That means you lose the blue color here. So this color will be what? Colorless. Just imagine it's a colorless after this. After some time. Now what is the reason? Why this is happening? Let me discuss. Now here, this reaction, what type of reactions are taking place when you dip zinc rod in the blue colored copper sulfate solution or copper nitrate solution? The blue color is what? Fading, and finally it is disappearing. The blue color is disappearing here. So finally what happened? Blue color, what happened here? Disappeared, become now colorless. Now why this happening? Let me see the reactions. First of all, this reaction took place. This reaction took place. Zinc reacted with copper nitrate or copper sulfate to give zinc nitrate or zinc sulfate plus copper. This reaction. So when you write in terms of what happened like this, your copper is copper plus 2 Zinc is zinc plus 2. This is the reaction actually. Understood beta? NO3 always will be minus 1 beta. NO3 minus 1. How many minus 1 are there beta? 2 are there. 2 minus 1 will be there, then 2 plus 2 will be there. NO3 minus 1, 2 minus 1 will be there. 2 into minus 1. Total will be minus 2, it will be plus 2. Now what reactions are took place beta? Zinc given 2 electrons to copper plate. Given 2 electrons. Right? Now zinc lost electrons or not? Which is losing electron beta in this one? Zinc or copper? Which is losing electron beta? Zinc or copper plus 2?
Zinc.
Zinc is losing, copper is gaining electron. Therefore, zinc converting into zinc plus 2, like this. Zinc converting into zinc plus 2. Which reaction it is? Oxidation. Okay. Now, copper plus 2 is gaining electron. Copper plus 2 converting into copper is called what here? Reduction reaction. Okay. So, zinc lost 2 electron, copper gained 2 electron. So, it is a best example. What reaction beta? Redox reaction.
Redox reaction.
Now, question: can you tell which element undergo oxidation and which element undergo reduction? Means zinc will undergo oxidation, copper plus 2 will undergo reduction. Very beautiful example, because we are not simply writing the reactions data. Simply, I am not saying that zinc is with an example. I am saying it with an example. You see, this is an example with a color change. Why? Because you see why the color change is happening. See, when copper plus 2 is there, copper plus 2. See, I am writing with the reaction with color actually. Shall I write with color? So, whenever you write copper plus 2 beta, whenever you write copper plus 2 always will be which color beta? Blue color. Blue color. But when you write copper beta, that is not having the blue color. It's a colorless compound. So in the reaction, if you observe what here happening, see, you see copper plus 2, isn't it? Copper plus 2, this one, copper plus 2 converting into what beta happen? Copper. Converting into copper.
Copper.
So color change is occurring here. The blue color changing into colorless compound. A fade blue color you are going to get immediately. Immediately you are observing the fading of that color, losing the color of that blue color here. So this is a very good example for what? To explain the redox reaction. It's a very good example. You have to remember this one beta. Any doubts regarding this one beta? You have any doubts?
No, sir.
Right, we'll move to what next example now. Now you observe one thing. Whereas if copper rod is placed in zinc sulfate solution, no visible change observed. Now let me see one more example beta. Let me take one more example. Now opposite I am doing beta. In the previous case I have taken copper sulfate solution. Now I am taking zinc sulfate solution. Generally zinc sulfate does not have any color beta. Zinc sulfate solution does not have any color. Colorless. Now how do they color and color compound? We'll discuss in the 12th class. Which will have color and which will have does not have color. We'll discuss in the D black elements of 12th class. Now it's a colorless compound. Now you are putting what in this one? Copper rod beta. Opposite you are doing it. You are doing opposite direction. Again zinc sulfate. Keeping what happen here? Copper rod. In this case, nothing is happening here. No reaction takes place. Now, why the no reaction takes place, we'll discuss in the electrochemical series here. So when you do opposite, what happens? Nothing is taking place. No reaction takes place here. What is the reason? We'll discuss in the class, next classes actually. Okay. Whereas copper rod is placed in zinc sulfate solution, there is no visible change occur. this indicates zinc is reactive metal than the copper. So what I'm saying here, so I will discuss more in next classes, but still I will say what happened, why the reaction does not take place here. Simple thing is what, when you compare zinc and copper, when zinc and copper both are connected, which is more active beta? Zinc is more active. Zinc is what? Actually more active. So that is the reason when you are keeping the zinc, which is active beta, zinc or copper? Zinc is more active, therefore zinc undergoing what happened here? Oxidation. Right? So this indicates zinc is what? More reactive than the copper actually. And similarly, if you take what happened, copper and silver nitrate solution. A blue color is developed in the solution due to formation of copper. Here also what happened, copper and silver, connect copper and silver, which is more active? Copper is what?
Copper, sir.
Active here. Therefore, this will undergo reaction, which will copper. Now again, what we are doing beta? Same thing. Silver nitrate solution I have taken. Silver nitrate AgNO3. Okay. Now this is a colorless compound. It is a colorless beta. Now you are keeping this one into this one, a copper rod you are keeping. After this, what is happening here? The copper rod, what is happening? You observe the chemical reaction beta. Copper reacting with AgNO3. See, copper reacting with AgNO3. What we got here? Copper nitrate. Nothing but copper plus 2 you got. Now what is the color of the copper plus 2 beta?
Blue.
Blue color. It is a blue color. Now this one will be colorless here.
Blue.
Which color we get beta? Which color we get? Because the program
Colorless, sir.
blue color. The formation of blue color indicates copper nitrate is formed. Okay, in the previous case, the colorless of blue indicates zinc nitrate is formed here. So in this case, what happened here? Copper, which is a colorless, right here it is, this part, which react with AgNO3. This is also colorless. This is also colorless. Copper is colorless means what happened? Copper of course looks orange color, but I'm saying in terms of what? Solution. This is not solution beta, it's a solid one. Now this is a colorless one, correct or not? This is a colorless one. Now when the reaction took place, what we got here? Copper plus 2 formed here. After the reaction, copper plus 2 is formed. Now silver nitrate definitely colorless because of absence of unpaired electron, where copper plus 2 is exhibiting blue color because of one unpaired electron. Now indicate what happened. It is also what happened, undergoing here what reaction? Oxidation. It is what? Reduction. We can give many number of examples based upon this copper and silver. Which is more reactive beta? Copper is what? More reactive when you compare with what? Silver. Understood? So based upon these three, we can write the reactivity order also. Which is more reactive beta? Zinc more reactive than copper, copper more reactive than the silver. Understood beta?
Yes, sir.
Any doubts?
No, sir.
Now? Do you have any class now? Do you have any class now beta? Do you have any class now? So let me finalize this one. Addition of oxygen, oxidation, addition of hydrogen, reduction, removing of hydrogen, oxidation, removal of oxygen, reduction, removal of electropositive, oxidation, addition of electropositive, reduction, addition of electronegative, oxidation, removing of electronegative, reduction, removing of electron, you see, removing of electron, oxidation, very important, removing of electron, oxidation, addition of electron, reduction, increasing the charge, positive charge, decreasing of negative charge is called what? Oxidation, and increasing of negative charge and decreasing of your positive charge is nothing but called your reduction reaction. These are things we have discussed already now. Now let me take some examples beta. We'll take some examples. Now let me see. Now this one will be oxidation reaction, correct or not? Increasing of charge. Next thing. Now here, what happening here? How do you say it is +6 oxidation state? Now how to identify the oxidation number? How to calculate the oxidation number? So I don't go in detail better. Simply I say what happened. How to calculate the oxidation state for this element. Okay. So first of all, this is a central atom. For the manganese, I'm calculating beta. I'm calculating the oxidation state of manganese. Right? What we're calculating? Oxidation state for manganese. Plus. Now, how many oxygens are there, beta? How many oxygens are there, beta?
4.
4 oxygens. Put here 4 oxygens. Now, each oxygen always, if it is oxide, the oxygen state will be here what? -2 beta. For oxygen, you have to take minus if it is oxide. If it is oxide, take -2. So, for one oxygen, how much you have to take? -2. Take is equal to. Now, overall charge, how much beta? Overall charge is how much is there? What is overall charge here? This is overall charge. How much overall charge is there?
-2.
-2. Now, when you do the calculation part, how much we get here, beta? Manganese is equal to how much we get here? 6. Now, let me take this example. Now, manganese oxygen state in this molecule in MnO4 -2. In MnO4 -2, what is the oxidation state? It will be oxidation number. It will be what? +6. Now, let me check for MnO4 minus beta. MnO4 minus, what will be the oxidation number? Take again manganese. Again, how many oxygens are there? 4. For oxide, the charge will be -2 is equal to overall charge how much beta? The overall charge is how much beta? -1. So we get manganese is equal to how much we get beta? Yes. So you can write now here the oxidation number for the manganese is +6. For this one here in this case +7. Now tell me which reaction beta? Now tell me which reaction? Now tell me here. Which reaction it will be? Tell me better.
Reduction.
Into +7. Now I told you when positive charge increases, oxidation reaction. Now you say it is
Oxidation.
You see here without this, if I see something, what happened? I see something. Can you say which is this reaction oxidation reaction? Is it possible for you? Impossible. By seeing this example, you cannot say this is oxidation or reduction reaction. Impossible. With electrons only, in terms of electrons only, we can say it is oxidation reduction reaction. So what we have to do? We have to calculate the oxidation number. Here also we have to calculate. Then we get, isn't it? Manganese increasing of charge. The reaction is called oxidation. Okay, I think you understood this one. I will take many number of examples better for calculating of oxidation number. Third example number. I2 converting into I minus. Now, which reaction can you say it is? Anybody?
Reduction.
Reduction.
Very good beta. यहाँ पर zero oxidation state. Okay. I2 molecule zero oxidation state. Neutral molecule 0. Now here, what is the charge beta here? -1. One iodine called -1. There are 2 are there. Multiply, you will get what? -2. Now 0 converting into -2. Increasing of negative charge. Increasing of negative charge. Or 0 converting into -2. Or 0 converting into negative. 0 converting into negative. It's nothing but called reduction. In this way, we can easily identify. So definitely what happened? It is a reduction reaction. Now I told you one definition for you. What is the meaning of oxidizing agent beta? What is the meaning of oxidizing agent?
Acceptor of
The substance which undergo reduction. The substance which adds electron, takes electron, gains electron. Simple thing. The substance which undergo reduction is called what? Oxidizing agent. Now iodine is undergoing here which reaction beta? Reduction reaction. Therefore iodine here oxidizing, isn't it? Iodine undergo oxidation, therefore the iodine undergo reduction, therefore act as what? Oxidizing agent. The substance which undergo reduction, iodine undergoing reduction, therefore iodine act as what here? Oxidizing agent. Right? This way we can easily explain oxidizing agent. Reducing agent means what? The substance which undergo oxidation. The substance which lose electron. The substance which lose electron or the substance which undergo oxidation reaction, the substance is called what here? Reducing agent. This already we discussed in the yesterday class. Now, do you have classes now? You have any class now? Yes, beta. Do you have any class now?
No, sir.
Okay. We'll do one thing, beta. These types of reaction we'll discuss tomorrow. Okay. The types of reactions are there. We'll discuss tomorrow, and we'll discuss some oxidation states also. How to identify the oxidation states also. Okay. Tomorrow we'll discuss that. Still, we have many number of topics are there, so we'll discuss that one here. Right, beta? So the types of redox reactions we'll discuss tomorrow, and